Hello friends, I welcome you all to my channel. At the beginning, I like to thank all my subscribers for subscribing my channel. So today I have taken a Hanoi Maths Olympiad question, that is to find the last three digits of 2005 power 11 plus 2005 power 12 plus 2005 power 13 up to 2005 power 2006. So which is based on number theory, and we have to solve some congruences. So first this expression will reduce to your to a expression in modulo 1000. So reducing the expression to modulo 1000, we get your last three digits. So any big number, to get the last three digit, we have to divide with 1000, and the remainder is the last three digits. So 2005 or 11 plus 2005 or 12 up to 2005 up to power 2006 modulo 1000 is same as your 5 to the power 11, because when 2005 divided by 1000 you are getting 5, so they are congruent, plus 5 to the power 12 plus 5 to the power 13 up to 5 to the power 2006 modulo 1000. Now let us see the factor 1000. 1000 is your product of two prime co-prime factor, that is 125 and 8. So first we will express this in modulo 125, then modulo 8, and we will solve it. So first the expression, I am taking the modulo 125 to write this: 511 plus 512 plus 513 up to 500 2006 modulo 125. Now see, 511 is the minimum power, 11 is the minimum power, and we are dividing with 125 equal to 5 power 3. So that divides 5 power 11 divides your 5 power 3, or when we divide with 5 to the power 3, it leaves remainder 0. So 5 to the power 11 leaves remainder 0. 5 to the 12 also leaves remainder 0. So the whole sum, whole series, each of the term when divided with 5 to the power 3 or 125, this leaves remainder 0. So I can write this is congruent to 0 modulo 125. So let us take this series sum as your x. That means let x is 5 to the power 11 plus 5 to the power 12 up to 5 to the power 2006. So x equals to, x is congruent to 0 modulo 125, that is first congruence. congruence 1. Next, coming to 8. 5 to the power 11 plus 5 to the power 12 up to 5 to the power 2006. Now we take modulo 8. Here you see 5 power 2, you will see 25. It is congruent to 1 modulo 8, because 5 square is 25 divided by 8, we get remainder 1. But when I am dividing 5 power 3, it will be your 5 modulo 8. 125, it will be, remainder will be 5 when divided by 8. Or we apply 5 square into 5, so 1 into 5, that will be 5. So 5 to the power twice k is any natural number, your congruent to 0 modulo 8, and 5 to the power 2k plus 1, that is odd, is congruent to 5 modulo 8. So now 5 to the power 11 is power odd here, then even, then odd, then even. It goes on up to your 5 to the power 2006. So at odd I'll get 1 modulo, 5 modulo, and in even I'll get 1 modulo. So how many numbers are there? You will see it will be 2006 minus 11 plus 1. That number is your 9996. That means half of this number will have modulo, when taken modulo 8, I'll get 5 remainder and half will be 1 remainder. So we'll write 5 to the 11 plus 5 to the power 12 up to 5 to the power 2006 is equals to 99996 divided by 2. First is your 5 modulo 8 plus 9996 by 2 into 1 modulo 8. And this we have taken as x. So I'll write now x is congruent to, it will be, if we divide with 2, it will be 4. Oh, sorry, very sorry. It will be not 999. It will be 199. It will run right. So it will be 1996. When you will divide it, it will be how much? It will be 998. Here also 998. Here 998 are common. So it will be into 5 plus 1 modulo 8. So now let us multiply this 998 with your 6. Or x is congruent to 6, 8 times 48 carries 4, then again 8, then 54, and 4 is 59. That is modulo 8. So I'll divide with 8. Let's divide 5988 with division 8. 756, 38, 54, 32, then 68. It will be again, it will be 8. 64, 4 is the remainder. So it will be 4 modulo 8. So this is the second congruence. X is congruent to 4 modulo 8. So we will solve now these two congruents. One is x is congruent to 0 modulo 8, 0 modulo 125. This one is congruent to 0 modulo 125, and second one is x is congruent to 4 so 8. So from these two, I could have applied this Chinese remainder theorem, but this is very small. That means only two equations are there, and here 0 is there, so it is easier. If one of this remainder is 0, it is very easier. Now please check how I am solving this. I'll write that when x is congruent to 0 modulus 125, that means it will be some multiple of x is a multiple of 125 plus 0. So x is equal to, from congruence 1, I can write x equal to 125 m plus 0. All this is same as your x equal to 125 m, when m is any natural number. And from second, from 2, congruence 2, this is from 1. It is your x is equals to 8n plus 4 when n is a natural number. We'll solve these two equations. So I can write in place of x 125m. So 125 with any multiple is congruent to 4 modulo 8n when n is again a natural number. Or this is same as your 125 times of m, or m times of 125 is same as 4 modulo 8. Now you have to think of the number by trial method, where what is the value of m, find m, so that this congruence is satisfied. Is satisfied. So let us take as 125 into 1, 125 multiplies 1. When it is divided by 8, it does not leave remainder 4. Does not leave as remainder. So m cannot be 1. Then if it is 2, m equals to 2, 125 into 2, that will be 250. 250 divided by 8, it does not leave remainder 4. So m is not equal to 2. Let us check for 3. It is 375. Again, it will not. So m cannot be 3. Now let us check is 4. If I take 4, m is equal to 4. 125 into 4. The left hand side of congruence will be 500. And 500 is congruent to 4 modulo 8. If we divide 500 with 8, 8 6 times 48, 20, 8 to 16. So 4 is the remainder. So it is true. Okay, so what is m? M equal to 4. So remember, m is equal to 4. What is x? X equals to 125m. X is equal to 125 times of m. M is 4. So into 4. So x is equal to 500. So the answer is 500. That means last 3 digits 500. Thank you for watching. Thank you for learning. Keep on learning.